Right now, we are going to be doing Ruby on Fails, effective error handling with Rails conventions. Speaker Talysson is a web developer and software architect and a true believer that we can always do better.
Can you all hear me? Yep. Okay, right. So as I just said, we're going to talk about Ruby on Fails, some effective error handling with Rails conventions. So a quick introduction. My name is Talysson. I'm a software architect and technical development manager at a Brazilian company called CodeMiner42. If you don't know us, we are a software boutique focused on Ruby on Rails, Ruby, and JavaScript. So if you need help on that, just reach to us. These are our handle and our website. So today's talks are going to be divided into 3 parts, where I'm going to talk about exceptions and errors, and then some anti-patterns, and then how we are going to actually achieve effective error handling. So let's start with exceptions and errors. So in programming, exceptions are a mechanism that you use to express unhappy paths. And then we use this mechanism to handle scenarios where we're able to recover from some of them. We call this an error scenario. So this is the main difference between an exception and an error. And in this talk, we're going to focus on some of the recoverable errors, like validation errors and authentication errors, payment errors, and so on. Now, in Ruby, exceptions are used to communicate between the raise method and the rescue function, the rescue part of the code where we're going to actually handle the code. So exceptions in Ruby are the base class of all the exceptions are usually the exception class, and when we have an actual error, like error that we can recover from, they're going to be descendants of the standard error class. So if we look at the Ruby error classes hierarchy, which is huge, we can notice that when we use rescue without specifying with error class, with exception class we're handling, it's going to default to standard error. And then when we use the raise without specifying what we're raising, we just pass the message, it's going to raise a runtime error. So it leads us to talk about some common error handling anti-patterns. So the first one is rescuing from exception just to be safe. You might think like, okay, so if every error extends from exception, I might as well just rescue from exception just to be safe, right? Like it's going to make our code way less brittle. I'm going to be able to handle everything that goes wrong. The thing is that exception is just too generic to be used, even if you use it just to be safe, even if you use it explicitly. So the thing is that error handling should not be used for states that are inherently invalid or you can do anything about it. If you rescue from an error and you can do anything inside that rescue block, like you might not be rescuing that and just let it crash. So that being said, rescuing from exception without a very good reason for that, because there are good reasons for that, if you do it without a good reason, actually makes your code less safe. So I'm going to show an example of that. So if you go back to that hierarchy and ask ourselves, what would happen if I rescue there? What would happen if I rescue from the base class, the exception class? So it would actually rescue from a lot of other exceptions that we don't want to, even including stuff like syntax error. So for example, if you have a file that has some syntax error there, and then you require that file inside a begin rescue block that rescues from exception, you will also be handling and rescuing from that syntax error. That is, in most of the time, this is not what you want. So this is why we should avoid rescuing from exception just to be safe. And the other pattern here is using error for flow control in the same context. So I added here an example of a cart items controller with some error handling there. And notice that in 2 different places, I'm using the raise function just to make our code to jump to a different part. But actually cause more problem than solves our problems. The thing is that the errors in the raise method, they should not be used in place where just a conditional branch would suffice. Doing that with errors is the same as using errors as an inadequate algebraic effects alternative, or even a go-to statement if you're old enough to know what is that. It actually makes our code harder to read, and also it's less efficient. Like, we can't forget that raising errors is not something that is very cheap. It's something that can be expensive to the computer to process. So we should do that only when needed. So using that example that we saw before, this is a case that just a conditional branch would suffice and solve our problems and make the code easier to read and understand what happens in each case. And now let's go back to the actual core content of the talk, which is effective error handling. But the first thing is we need to ask ourselves, what are our goals? What we need to achieve to get effective error handling? So our goals are going to be, we want a consistent and pragmatic error handling strategy. We want to make errors scenarios explicit. We want to provide enough information for the call side to make decisions. We want to follow conventions and the Rails way. We don't want to escape any of those goals throughout this talk. So the first thing to achieve these goals is being intentional. This is very important. What I mean by that is that we shouldn't just try to guess what are the error scenarios in our code. We should discover them. We shouldn't just write the happy path and then run it again and again until we find all the places that it can break. We shouldn't do that. We should discover it beforehand. Before you even write any code, it's important to design your code accordingly, considering all the unhappy paths that might happen and what would you do to handle that in your code. Remember that errors exist to communicate with the call side, not with the internal side. So the call side needs to have enough information and enough capabilities to handle that error that you just raised. And it's important to remember that you should only handle what you can recover from. Don't put your code in a state where you can't do anything about an error. If you have this kind of situation, just let it crash. So here I added a code that doesn't have any error handling at all. That is just a checkout service. And it's divided in 4 different parts. It's the creation of the cart, the order, some fraud detection, and then the processment of the payment, and then we actually persist the order in the end of it. And if we look at this code and then try to discover what are all the unhappy paths that we have here, we can begin to list it. Maybe when we're trying to create the order, maybe the item is not available anymore. Or maybe we're just out of memory and we can just instantiate any of those items objects anymore. Or maybe we detected a fraud and all the flows should be interrupted at that point. Or maybe the fraud detection is down. Or maybe when we try to actually process the payment, the credit card data is invalid, or there's insufficient funds in the credit card, or maybe even the credit card service is down. Or maybe when we try to save the order, for example, the order might be invalid, or even the database is down. Of course, there's a lot of other cases, but as we talked before, we don't want to try to handle scenarios that we can't do anything about. So let's just try to focus on all the business scenarios that might fail in this checkout service. Okay, so now that we do know what are the error scenarios, how do we do them with them? How do we handle them? So the question here is, how do we express these errors scenarios in our code in an explicit way? So we begin doing that by creating custom error classes that express exactly what happened. This is especially important when a method can fail for more than a reason, and then the call site needs to know what was that reason that caused the failure, or even if you need to add more information to the message than just the message to the error. Maybe just the message is not going to be enough for the call sites to make decisions. So in Ruby, when you're going to create a custom error class, it should be a descendant of the standard class error. And if you need to enrich the information that is provided by that object, you can do that by adding some methods to that custom error class. So here we created an example of how to create the item not available error. If it happens again, please let me know. So the first thing we're going to do is extend from the standard error class. As we spoke before, this is a rule. And then we're going to use the super initializer to pass the message to the standard error class. And then we're going to enrich this object, adding some methods and attributes to make it clear for the call site exactly what happened, what item was not available when we tried to purchase it for some reason. And now we can go back to our checkout service and understand, okay, where is the part of the code where this error scenario happens? Where can I raise this error? And we found out that it happens inside our loop that goes through the items. And then at that point, when the item is not available, we're going to raise that error passing the item ID that we were receiving in the constructor. And then when we go back to the controller, that's going to actually call this checkout service and be able to handle when the item is not available. Then we just add a rescue there, making it very explicit on the call side what happened, what was the ID of the item that was not available, and then the controller is able to send some correct status code or anything like that in a way that is completely encapsulated inside this, the service that we just created. Okay, we do know how to create and make the error scenarios explicit, but it's important to remember that we need to abstract the errors the same way we do for logic. Like if you encapsulate some gem or something like this inside the service, it's important that all the errors from that gem don't leak through that contract of that service. Otherwise, whoever calls that service doesn't know what caused that error. So here I created another, we go back to the example that we had before, and we take a look at that one scenario that we know that when we try to save the order, if some of the object of the order object is invalid, it's going to raise an active record invalid error for us. And maybe at this point you're just wondering like, okay, I just need to go back to my controller and add a rescue for that, right? The thing is that this is actually leaky error handling. This is something that makes it not clear what caused, like what record was actually invalid when we were trying to persist that order, when we were trying to do that checkout through the checkout service. So how do we fix that? It's important to, as we do for code where we avoid leaky abstractions, it's also important to avoid leaky errors. The origin of an error should be very clear on the call side. You shouldn't need to open a class to know what caused that error. And it also counts with any gem-specific errors, even though you might think like, oh no, I think this one is okay. And then at some time after that, you're going to go back to that code and you will understand what exactly caused that. And if you feel like you're going to lose some information when you're trying to like encapsulate all of our errors, you can remember that the errors cause method exists. So we're going to take that order invalid scenario that we just saw, and we're also going to create a custom error class just for that. That's going to be used inside of our checkout service. So we go back to our checkout service, and now instead of just rescuing from that record invalid in the controller, we're going to go back to the checkout service where we know, we're totally sure that what caused that record invalid was because our order was invalid, and then we're going to re-raise the order invalid error inside the checkout service, and then now we have a safe way to do it in the controller. So we go back to the controller and add a rescue clause just for the order invalid, in a way that we don't leave the record invalid error to leak. And it also happens for any gem-specific error as well. So we just saw that we have the fraudulent customer scenario, that when some fraud was detected inside the checkout service, we can also create a fraud detected class there to represent that scenario, and then we're going to re-raise it, and we'll be able to add a rescue clause in the controller. The good part here is that if you're just using regular rescue clause, you can add some specific ones when you have some specific behavior for that error scenario. For example, let's say that if we detect that the user is fraudulent, we just to lock them outside of the system until we do something about it. And maybe at this point you're thinking like, wait, like fraud detection is a very important thing. I can't afford to lose information about that error. I need to log it somewhere. I need to do something regarding this. So the thing is that due to the fact that you're raising inside a rescue block, Ruby will already automatically fill the error cause method in that error that you just raised, pointing to the original error that you had before. So if you have that fraud detected error in your hands that was raised inside a rescue block, and you need to access that original fraudulent customer error to know what was the ID of the customer, or maybe what was the reason for that fraud to be detected, you can just use the error cause method and everything's going to be there for you. But it's also important to leave your options open, and you don't lock yourself in some set of abstraction that you do in your code. And you can use polymorphism for that. So sometimes you are in a situation where you need to handle a lot of different errors in different ways, like we just had in our controllers. But sometimes you want to handle all of them in a single way, all of them in a single approach. But what happens if you forget to add some of them in the list of everything that you need to handle? This is going to cause bugs, and the worst case scenario is going to even lose money for that. So we can use polymorphism to keep your options open and thus suffer from this problem. So sometimes we need to handle a family of errors in the same way, and listing all of them is not something that is very reliable. It's actually very error-prone. And you don't need anything fancy to solve that. You just can keep it simple. You just can use the layer supertype pattern for that. And maybe you're wondering, like, this dude just said we don't need anything fancy, and then say the fancy name like layer supertype. I'm sorry for that, but I'm going to tell you a secret. We already do that with Rails all the time. We just don't know this name. But I'm going to show you some examples how we do that with Rails. So here goes. When you use application controller or application record or application jobs, all of those are the usage, are a usage of the layer supertype. When you have a superclass, that is like the root of all the classes that are in that layer, in that responsibility layer. So we can do that the same as these with errors as well. We can create, for example, for the checkout service, we can create a base class called checkout service error, and this is going to be the base class for all the errors that happens inside checkout service. And then we modify every other of them that we already implemented, and then change it to inherit from checkout service error in a way that now, if we need to handle all of the checkout service at once, we can just use the superclass on that, and then when we need to specific situations to handle some of them, polymorphism is gonna keep our options open in a way that we don't lock ourselves. Okay, I would have to list all of those. Okay, so we kept our options open. We know how to make error scenarios explicit, but we still need a centralized strategy to make our code, our error handling strategies to be actually reliable. So let's think about backstory here for a second. Let's say that one day I have an e-commerce and we have a checkout and I have my error handling and tracking in place. And then I check into my monitoring service and I see there's a lot of like alarming message there, like looks like the users are not able to check out their orders and are not making any money for that. And I begin to panic, and then I remember that I do have a login service in place. And I checking the code, okay, I do have logins for that. You can just go back to that login and everything is there. That's awesome, that's very good. And everybody's happy again. But then someday you notice in your monitoring service that you're not, for some reason, you're not shipping your products. Like your users are not receiving their projects for some reason. And then you check your monitoring service and you remember that one other time that you checked your monitoring service and it told you what was happening, and you was feeling way more relieved because you were confident that you go back to your login service and everything's going to be there. And you go back to your login service and nothing's there. Like there's no login message telling what's going on. And then you panic again and go back to your code and notice that you just forgot to add the login service in one of your most important error handling parts. So this is something that we want to avoid. This is something that might happen with anyone, and just forgetting to add some login or anything like that, we need to find a centralized way to solve it in a way that we don't need to remember to put it everywhere. So let's use a centralized strategy for error handling. So the thing is that not centralizing it causes a higher chances of inconsistencies, like we just saw. And this is especially important when the app has multiple entry points. And by that I mean that when we have API requests and requests coming from forms and jobs or, I don't know, WebSockets or anything like this, like all of those happen in different ways. And we need to find a way to make it centralized. And just using rescue from doesn't actually make it centralized. Like it just make it, I don't know, automatic, but it's not actually centralized. And it's also important to take care not to over-centralize it. So to have a centralized error strategy, we begin by defining an error reporter. So the error reporter should be defined inside an initializer. The name of the class doesn't need to be error reporter, it just needs to be in initializers. And also this class doesn't need to extend any other class. It just needs to have a report method, where the first argument is the error, and the other ones are some named arguments with some metadata about the error. And the next step is just you're going to subscribe an instance of this error reporter to the global Rails error subscriber. This is something that is native to Rails, and it's important to know how powerful it is. Okay, so now that we do have this reporter, how do we actually use it? How useful is that? So the next step we're gonna do is create a module called error handling that is gonna have a report error. And note that here, we don't need to pass all this metadata about the error, like where it happened, what was the code for that, what was the severity of that. You don't need to pass any of those to Rails. You just need to pass the actual error object. And then since it's in the model, remember that a report error is gonna call, the report error method is gonna call the report in our error reporter that we just saw. And now we can go back to our controllers, back to our jobs, and we can just include that error handler in a way that all of those places now have a report error method that you can use in a centralized way everywhere that you need it. So if you go back to our checkout service inside that fraud detected error and called report error there, you're going to see that what is logged by Rails is reporting, because we wrote that in the puts method in the reporter. But notice that I didn't have to specify and tell the reporter that problem happened in a controller. It already knows it. Like all the metadata for that error is already inferred by Rails and passed to us in a way that we can use it the best way we need to. But of course, sometimes we might forget it. We just might forget to call the report error, or we might forget to rescue from some important error, and we don't want to lose this information. So pay attention to that puts reporting and error calls and the context that I put in our error reporter, and see that in this controller, I'm just raising some generic error there, and I'm not even trying to handle it. I'm not rescuing from it. I'm just letting Rails deal with that for me. And you're going to see that even though I didn't do anything special besides subscribing my error reporter to the Rails global error reporter, it also going to log for us everything that calls that error, even though I didn't rescue from that. And notice that, again, it's reporting what error happened and where it happened. It even tells us what controller did happen. And of course, there's a lot of more information that I just omitted there. It also works not just for controllers, but every entry point of a Rails application. So if you do that in a job as well, you're going to see that even if you raise inside the job, Rails is going to rescue for us and just pass it to our error reporter. In this case, it's a little different because I used Sidekick to create the example. So the actual error is going to be a Sidekick error, but the error cause contains the actual error that we raised in the job. Okay. So the next step, now that we have a centralized error handling, is that we want to use good conventions. Like at this point, we talked about creating some other classes for errors and stuff like that, but it might still be too cumbersome to write new classes for errors all the time. So how do we create good conventions for that? So the thing is that Rails' strengths stem from this convention, right? This is what we actually love about Rails. But the sad part is Rails doesn't provide strong conventions for errors. Besides the one that we have for active record, like if you raise a record not found, it's going to return a 404. Besides those, Rails doesn't have a lot of strong conventions for errors. But we can always create our own conventions following the Rails way. So if you think about it, good Rails way conventions always provide two things. The first one is that they are reliable and the safe defaults, that we can just use that as our first step. And then we need a practical way to break them when necessary. We don't need to go all the way around to try to break a convention. It should be something that is very practical. So here's an example how we can do that. We can create, again, use the layer supertype and create an application error that extends from the standard error, and then we create a convention there that all of those errors that extend from an application, they're going to have an SJSON that can be used to send the error through the network. And if that subclass of the application error also has a details, this is also something that we're going to include in the SJSON response. And then if you need the error type to show something to the whoever is consuming that error to be able to handle it, for example, in a JavaScript or anything in the front end, we also have the error type inside the JSON from that errors as well. And maybe at this point you just wonder like, okay, we do have that application error. I can just go back to my application controller and add a rescue from to that application error, right? And no, the question is we don't do that. The thing is that application error is too generic for that. Using application error here, it would be kind of similar effect than rescue from exception that we spoke at the beginning. That is something that we should avoid. So how do we define and use an actually safe and centralized default using a convention now? The thing what we can do is actually create some other subclasses of this application error, for example, a not found error, in a way that if I do have some specific scenarios, error scenarios that should be made explicit in some of my use cases like product not found, I can extend from this not found error, and now we can use this not found error as a safe default. Because we know that every time this specific subclass of application error, this not found error is used, this is something specific for like when we should use 404. We can use it in a safe way. We know that there's a lot of other more specific errors that won't conflict with this one. And then if we need to break this convention, like for some reason, in this situation, I do have a not found that I don't want to return 404 for some reason, we can just go back to our controller and then add a specific rescue for that and then break that convention successfully in a way that we don't affect any other place that use that approach. Okay, so maybe at this point, some of you might be wondering, like, what about application flow strategies like result objects and monads or railway-oriented programming and all of these? So my question for that is, I actually think they're great. I don't think they're bad at all, but I think it's important to keep them contained. Otherwise, what you're gonna cause your code is something like this. Like you have some methods that interact with normal Ruby objects, and then when you get to one method that needs to work with result objects, everywhere is gonna be necessary to handle that. So this is something that we usually avoid. So as I say, I don't think they're bad. I think abstractions are good design to express the multiple flows of our app. But I think it's important to stop them from coloring all of your code in a way that all of your code needs to speak monad or result object or any of those. You should contain these strategies in use case abstractions. And when I say use case abstractions, I mean like services and operations and interactors or whatever you want to call them. And then you use ordinary error object everywhere else. So if your Rails app has a flow similar to that, like you have some input layer, like a controller, or a job, or a channel, calling a use case, and this use case is responsible for juggling between your models and your other services and the infrastructure of your code, you should keep your application flow strategies inside the use case layer facing the input layer in a way that all the rest of your code doesn't need to know how to speak result object or how to speak monad. Before closing this talk, I want to leave just some takeaways based on everything that I've been talking about. So the first one is, don't use errors for flow control. I know this sentence is something that's repeated over and over, and sometimes we just don't even think about it and think it means that we shouldn't use errors as a whole. And this is not the case. Like, understand what exactly means, like, don't use errors for flow control. Be intentional and explicit with our error scenarios. Don't just find out when something breaks. Design them, discover them. Abstract errors the same way you do for logic. Like sometimes we spend a lot of time trying to create a very good abstraction to represent the concept that we're trying to represent in our code, but then we leave all the error handling to just leak through to the rest of their application. Don't do that. Reducing consistency, centralizing error handling. Create and stick to project convention. This is important. Like, don't just try some approach and then leave it there. Like, stick to it. Use that convention the same way we do with Rails conventions. And last but not least, keep approaches that influence your whole code content. Thank you, RailsConf.